Today's topic is something very technical, soil health and nutrients. Fortunately, we have with us an expert in the field. She's a farmer herself, 9th generation, I believe, and a technical authority, has written many technical standards, and she's also an entrepreneur. But before I turn it over to her, let me say hello, everybody. It's good to be with you once again. And now let me turn it over to our expert today, Penelope Nagel. Penelope, please, your turn.
Thank you for the introduction. Again, my name is Penelope Nagel. I'm with Soilytics, powered by persistence data mining, where we're creating scalable and efficient agricultural testing solutions for the climate, for the farmer, for soil health, and better living. So soil health is a big buzzword nowadays. So it's really important that we kind of step back and look at what soil health is defined at, because basically it depends on which way you're looking at it. So the basic definition is that can it sustain plant and animal productivity. That's the agronomic focus, and that's part of what we're going to be focusing on today. It also enhances biodiversity. So that's a more ecological focus, maintaining and enhancing water and air quality. As we probably all know, our environment is dependent on the soil. It impacts the air, it impacts the water, it impacts the food we eat. It also supports human health and habitation and provides a place to sequester carbon that's in the atmosphere. So today we're going to be talking about measuring what's in our soil. So if you can't measure it, you can't manage it. And reliable data is essential to managing performance in any fields. So the real question is, how good are your metrics when you make decisions that are impacting your fertilizer input costs, which on my farm account for 32% of my input costs. So conventional agricultural practices have led to soil degradation. It's a threat to our climate, our food security, and basically to humanity as a whole. So better farm management practices are needed to manage our soil and our plant health. Basically, we've discovered that in managing our soil health, we're actually able to grow healthier food, not just for healthier people, but also for a healthier planet. So the benefits of improving soil health are the environment, our food quality, economic security, as well as water sustainability. Because unfortunately, if we're putting things on the soil that are degrading the soil, we're impacting our water as well, which impacts our oceans, our air, and everything around us. So we've come up with a solution for actionable and accurate soil testing that's essential to address soil nutrient deficiencies. Now, the United Nations has come up with a number of sustainable development goals, including zero hunger, responsible consumption and production, climate action, life on land, life in the water, and partnerships for these goals. So today we're speaking to you as part of partnerships for these goals. So let's get down to brass tacks and the dirt. Profitable acres for farmers is what we're looking to accomplish here. Right now, soil testing is extremely expensive. For the most part, it's inaccurate and it's done on a level that's just not granular enough to be making solid decisions. So a cost-effective tool like the Soilytics Smart Probe can enable farmers to go out, scan the soil in a standardized method. So we've recently created a standard. We've also been working with the Food and Agricultural Organization of the United Nations to make this a standard globally, which is very important because we want to make sure we're giving accurate information. So how it works is we basically go out into a field, we scan the soil, preferably multiple data sets per field, or a sample every acre, depending on the plot size that you're working on. That information is uploaded into the cloud. We analyze it. We give you back nutrient data and give you a scale to help you understand what this means. So the access to the data is available via our portal, and then you can variable rate apply so that you're getting better results than traditional methods. So right now, chemical methods are taking one sample, generally every few acres, and making a decision, again, that's affecting 32% of most farmers' input costs. That's a lot of inputs. Soilytics enables you to get a basic tests, the same test for less money, and have that information on a more granular level. So there's a lot of other tools out there. Traditional sampling is really the number one method out there that's being used. There's some other methods that do subsurface or surface. Aerial only does surface testing. Satellite imagery is looking at surface testing. And right now the elements stratify in the soil. So we can't just figure out what's going on underneath as far as true soil health without actually digging into the dirt. So the opportunity here in the market is the global market of $2.4 trillion in the agricultural industry. So we're looking to go out and partner with other people and farmers to create a more strategic method for truly practicing precision agriculture. So I want to get into some of our studies because a lot of this information people on this call might already know. But we went out into a couple fields. This is an example where we had done in previous tests, as you can see in the lower left-hand corner. This was based on zones. These zones were created based on the yields. What we did find out, as you can see here in the lower right-hand corner, is that depending on the element that was missing, it created a totally different map. So unfortunately, one size doesn't fit all. So we were able to achieve 27 data points, whereas previously they were looking at 3 soil samples in this field. We were able to save $1,310 in input costs and decrease 3.7 tons of fertilizer in this field alone.
Okay,
So it's
can I
important.
just stop you there? And let's go
Yes.
back to that slide. I want to know how you saved that input cost and how you told them to reduce the fertilizer. What is it in the data that gave you that knowledge?
So we were able to take 27 data points instead of 3 data points. So the cost for all of these samples, for the 81 samples across this field, cost $207. Previously, they were getting 3 samples out of 9 data points. Again, this was based off of yield maps and what was going on. So we were able to make a recommendation in this particular 160-acre field. We did a sulfur application to treat for pH. This was very important. That was one of the limiting factors. So part of what the technology does is it helps identify in an area that's not producing what those limiting factors are. So pH is a huge deal. If we're just taking, 3 samples and sending them to a lab, we're not really understanding what's going on as far as the soil health in that field. So zones vary significantly.
So the more you know about your soil, the more you can fine tune your inputs. Is that what it is?
That is correct.
Right.
Let me go over to this slide again, showing how it dramatically changes the more points that we're looking at. So we were able to take fields where there was huge variations, reduce the variation while increasing the crop yield and decreasing the cost. Again, I'm just going to go through some quick. This was a nitrogen map. We were able to stop the flat rate application, which was impacting the water as well. So the soil health has a direct impact. So if you're over applying nitrogen, unfortunately, you're not only wasting money, you're also causing something that could potentially hurt the environment. One of the best examples of the success was this field in Hubbard. The Hubbard field had been previously studied 4 years prior by a fertilizer company. We came in, and because we were able to get so many more data sets, the original zone map looked like the center map here, and we had huge variations within the field. As you can see, there were obstacles within the field, so that's not a perfect grid map. On this particular field, the yields increased over 3 years by 4.5 tons per acre, to 7 tons per acre, which was an $81,000 increase in revenue, while we were able to decrease the application cost for lime by $21,000. So in this particular field, again, pH was an issue. There was a lime application. They were able to apply those inputs based on more granular data.
Okay.
So these case studies are basically proving that the more granular the testing is, the better variable rate application you can do, which is going to increase production and decrease costs.
Okay. I get that. I get that completely. You have more data, you have better data, you make money, the farmer makes money, and the environment gets saved, right?
Correct.
Right. Okay. I get that. All right. Please
So
continue.
on average, we were able to save about 18%. When we look, we basically include all of the information in our data. This has been published with the International Society of Precision Agriculture. So if you're looking to do some deeper reading on this study, in some fields, we were able to save them 38%. And in some fields, we were able to save 1%, but on average, it was about 18% across these 7 fields.
Okay.
So just put it all in perspective, a buttload, which is a measure in the wine industry, is 126 gallons. It takes approximately 60 gallons of nitrogen per acre to grow 180 bushel acre corn. So on a 100-acre field, at a 15% decrease in fertilizer costs, the farmer will save over 7 buttloads of fertilizer. So globally, with 3.2 billion acres, we can save over 224 million buttloads of fertilizer, nitrogen alone, each year by variable rate application. So we're looking for research partners as well as financing and partners for customers. We've got a number of development customers. We did win the R&D 100 award at the end of 2019, and I've worked with a number of esteemed agencies in order to help standardize this method, working on a global scale so that we can help farmers make not just more bushels, but more profitable bushels.
Okay. Sounds very impressive to me that we are using modern technology to save the environment, to get the farmer more money. And incidentally, you also make some money. That's nice, you know.
Everybody wins.
Right.
And one of the most fascinating things that I didn't add into the presentation is the animal nutritionist that actually use these fields for feed for cattle actually reported that it was 50% more nutrient dense, the crop that was produced, with 28% more protein. So in being able to accurately apply fertilizers or amendments, in this case, limestone, we were actually able to produce more nutritious food. And I always like to plug in that in 2020, the first thing they told us all to start using as a supplement was zinc. And what we find is there's a lot of fields out there that are zinc deficient, meaning it's not in our foods anymore. So if we can find those limiting factors to produce better food at higher yields at less costs, everybody wins.
So you're just bringing soil testing into the modern age.
Correct.
Right. Okay.
If you've seen what some of those methods, they weigh stuff and then they burn it and then they weigh it again. Really some of the methods that we've been using previously are kind of more along the lines of what a caveman would use. So we're bringing it a little bit higher to a higher standard as far as what technology can do to help us grow better food and protect the environment.
Okay, so now let me ask you how all of this fits into your work with the company Vega MX, which is sort of the umbrella group for all of these videos.
Right. So we've been collaborating with Vega MX on integrating satellite data. So one of the important things that we've seen is integrating the crop cycle prior to the testing to understand where there's different things, to really be able to pinpoint what a limiting factor is in a field based on 4 different growth cycles in the crop's health, right? So satellite data is extremely important for determining what's going on in the canopy during the growth cycle. But it all starts in the soil. So integrating these 2 technologies together basically enables us to find out what's truly going on in the field, what those limiting factors are based on the growth stage of the crop, and then treat those for the next crop cycle with, proactive soil testing.
Okay, so your data is directly from the ground, and you are merging it with data from the collected from space, so that you have both sides of the picture, and you are able to give, first you study it from the space side, then you study it from the ground side, and you come up with practical recommendations.
Correct.
Right. Okay. I'm happy to hear all this because I know the world needs to improve the way it does agriculture. Today morning, I had an interview with a modern farmer in India who said that he cannot compete against chemical agriculture because there's too much subsidy on chemical agriculture based out of old habits. Right? So we can't. So it's very clear that, the chemical agriculture is creating major problems for soils everywhere. And if your method can say, listen, you don't need so much fertilizer, guys. These standard guidelines don't make any sense. It's your field, and you need to know which part of your field is what. You apply the fertilizer and everything based on that. Then I think that will help save the soil everywhere and keep its productivity going on for a long time.
Yeah, I think we've been kind of just going off a flat rate recommendation for a long time. We believe that the crop is taking this, so we're going to tell you just to put this flat rate across the field, which isn't necessarily true. I have some groups that I work with down in the southern states here in the USA, and they were saying that there's a lot of nutrients below, and they were adding cover crops in that were actually drawing those nutrients up from the depths so that they were available for their cash crops. So that's an interesting turn of events where it turns out a lot of these nutrients are there. They're just so deep that the plants can't get to them. So monocropping has definitely influenced this happening. And by rotating our crops and making sure that we're rotating them in a fashion that promotes the next growth cycle. So one example that's very common here in the US is, we grow corn and then we grow soybeans. The soybeans help pull some of the nutrients into the ground and pull in nitrogen so that we're not having to do so many applications of synthetic fertilizers.
Okay, Penelope, thank you so much. I just want to say once again that she's part of the Vega MX team, and this video is one in the series that Vega MX and I are doing together to describe what is precision agriculture. And certainly what she's doing sounds very precise to me. It's like, okay, guys, I'll get you the exact data that you need down to the smallest part of your field. So Penelope, any final words before we end?
No, thanks. I look forward to working with some of your viewers and learning more about their needs as far as crop recommendations and soil health management.
Okay, so let's say bye to the viewers. Bye-bye. Next time I'll have another expert with me. Until then, bye.
Bye-bye.